All right, good morning, good afternoon, good night, and good evening. In this video, we are going to be working through the following exercise on box plot construction from lecture set number 2. So when we are building a box plot, what we are trying to do is visualize the 5-number summary. So the first thing that we would want to do is work out the 5-number summary for the data set that we are considering. So in this particular illustration, let's first count how many values we have. Okay, so if I just quickly indicate the observation number above each of the values, I notice that I have 12 observations in the data set. This is important because when we go to find the median and the quartiles, we have to know if we are going to be averaging between 2 points or just pulling a value directly. Our 5-number summary, as we have already discussed, is composed of 5 numbers. The minimum, which here is 12, you'll notice that these values are actually ordered for us already. So these values in the data set we are considering have been pre-ordered from smallest to largest. So we know the minimum is 12. We know the max is 160. Okay, so we have to find Q1, which is the first quartile. We have to find Q2, which is the median, and then Q3, which is the third quartile, and then the max. Now, in general, my recommendation is to always do the second quartile, the median first. So I'm going to give myself a bit of space here, but I'll move some stuff around should I need to afterwards. Okay, so Q2, which is the median. This is going to be the center point of our data values. So we have 12 observations. So that means our median in this example is actually going to be located right here, because you'll notice that on each side of Q2, we want to have the same number of values. So if we place Q2 here between 6 and 7, that gives us 6 observations below the median, 1, 2, 3, 4, 5, 6, and 6 observations above the median, observations 7 through 12. Now, because we are between two numbers, that means that Q2 will be the average or the mean of 62 and 69. So if we average these two values together, we have 65.5. So our median for this illustration is 65.5. Okay, now that we have Q2 placed, it's easier to determine where Q1 and Q3 are going to be located. So basically, Q1 is going to be the median of the lower half of the data. So Q1 will be the median from observation 12 to observation 62. So it is the median of the first 6 values. Notice that because Q2 sits between observation 6 and 7, I am only taking the lower half in my Q1 calculation. If we had an odd numbered valued data set, Q2 would be the middle number, and then we would include it in our median or in our Q1 and Q3 calculations. So there is a bit of nuance here. Okay, so we only want to take the median of the lower half. Now, we have an even numbered lower half. We have 6 numbers in the lower half of the data. So that means that our Q1 is going to have to be the average of the 2 middle values from the lower half, which are 31 and 42. So if we average that, we have 36.5. Okay, so Q1 is placed here, right? And again, you can think of this as the median of the lower half. So these calculations are very similar. When we go to do Q3, it's going to follow the exact same process, except with the upper half of the data set. Okay, so we have Q3. This is going to be the median of the upper half. So this is the median of observation value 69 through 160. Same logic. So this is going to be the average of the two midpoints, which are observations 9 and 10. Okay, and then these are the values here. All right. Okay. And then finally, we can note down the max. Okay, so the maximum here is simply the highest value, which is 160. All right, so our 5-number summary is composed of the value 12, the value 36.5, the value 65.5, the value 84, and the value 160. So that's the 5-number summary for this particular data set. Right? And again, the quartile calculations, those are median calculations. So they're just medians of the two halves of the data. And the number of observations that are available to us, those are important because it dictates where the numbers, the quartiles are going to be located. We have an even numbered data set, so Q2 was right in the middle of the two center values. And then we had two even numbered halves, same logic. So Q1 and Q3 then got placed in the middle of the two middle values. Had we been in a situation where we had 5 observations on the lower half and 5 on the upper half, then it would just be the center point. So odd numbered data sets don't require average calculations, even numbered data sets do. All right, now we want to build a box plot. So the next thing we have to do are compute our limit rules. Okay, so in the look for we have two limits that we need to calculate, the lower limit and the upper limit. The lower limit is Q1 minus 1.5 times the IQR. Okay. So we need to compute the IQR. We already have Q1. All right. So I'll just put a star here, and then I'll do this calculation up here. So from the 5-number summary, we can easily work out the IQR. So the IQR is simply Q3 minus Q1. So that's 84 minus 36.5. And that gives us 47.5. Okay. So the IQR for this data set is 47.5. So that means our lower limit is 36.5 minus 1.5 times 47.5. That gives us a lower limit of negative 34.75. Okay. Now, the fact that this number is negative is perfectly fine. So if you compute a lower limit that's a negative, that's not an issue. That is plausible. What we would do now is we would basically just ask, so is there a lower outlier? And to check this, all we have to do is take the values in the data set and see if they are below the lower limit. So our lower limit is at negative 34.75. Our smallest value is 12. 12 is bigger than negative 34.75. So therefore, we would say no, since no value is below negative 34.75. Okay, so that's how we use the limit rules within box plot construction. Now we have to do the exact same thing for the upper limit. So we would have the upper limit is Q3 plus 1.5 times the IQR. So this is going to be our third quartile, which is 84 plus 1.5 times 47.5, which is 155.25. And then we use the same logic, but we go in the opposite direction now. So with a lower limit, we wanted to know, is there any point below the lower limit? With the upper limit, we want to know, is there any point above the upper limit? So in this case, we can see that the maximum value in the data set is 160. 160 is bigger than 152. So if we were to pose the same question, and I'm just writing a little simpler upper outlier, like upper outlier, then we would say, yes, since 160 is bigger than 155.25. Okay, so we have an upper tail outlier, 160, but we have no lower tail outlier, right? Because nothing in our data set is below negative 34.75 in value. So now we can build the box plot. All right, so box plots can be constructed vertically or horizontally. I will build this one. It doesn't matter which way you do it, but I'll just build it horizontally because I have lots of space. Okay. All right, now what we need to do are establish some ticks and build a scale out. Okay, so, okay. So just trying to space these as evenly as possible. This is not looking good. I'll start this again. Okay. When you go to do this on the assignment, you can be a little more strict than how I'm being now. You can use graph paper if you're using a tablet, or graph paper if you're using regular paper. You could also use a ruler so that you get your axis spacings correct. But the idea would be that each of these points are roughly, well, and if possible, exactly evenly spaced. Okay, but this is just for illustration, so you get the concept down. Okay. Okay, now I'm going to pick my scale. So I'm going to increase by tens. So each dash is a jump of 10. Okay, but I'm just filling out every other dash for space considerations. All right, so you can see here that I have a little bit too much room. My highest value is 170. So now I'm just going to cheat a little bit and throw this thing out. All right, so let's see how this looks. Okay. All right, now what I'm going to do is I'm going to mark down the values that I computed on the box plot. Now you can do this in different ways. There isn't a right or wrong way to start the process. So what I'm going to do here is I'm going to mark the quartiles first because they are consistent across every box plot. So we have 36.5, 65.5, and 84. So 36.5 would be roughly, let's say, about here. 65.5 would be, let's say, about here. And 84 would be roughly here. All right, and then I'm going to connect these together like this. And now I have my box. Okay. So again, each line on the center part of the box those represent the quartiles. Okay, so you don't have to label these in your solution because it should be obvious to the graders and whatnot. But again, this is Q1. The center box or the center line of the box is always Q2. And then this is Q3. Okay, now what we have to do are mark down where the tails of the box are going to go. So the way that this works depends on the result of the limit check. So for example, we determined that there was no lower outlier. So the lower limit was at negative 34.75. So we have no outlier on the in the lower half of the data set. So the minimum value that we mark down here on the tail is just the minimum that we computed in the 5-number summary. Okay. So this is our min because there's no outlier in the lower half of the data. So this value here is the minimum. Okay, now, because we have an outlier on the upper half, the way that we treat the positive part or the upper part of the data set is different from how we treated the lower part. What we're going to do first, because we identified an outlier, is mark down the upper limit value directly. So my dash line here is going to be at 155.25, which is, let's say, right about here. Okay. And then I'm going to connect this to my box as such. And then I am going to put a point or some shape of choice here to mark the outlier, which is the maximum value from our data set. So this here is the value 160, and this dash line here is the upper limit. And again, the reason that we construct the box plot in this way is because we have an upper outlier. If we didn't have an outlier on the upper side, I would just draw the whisker where I have UL at the max. So we only mark the points individually if they are designated as outliers. You can have outliers on both tails, and you can have multiple outliers on both tails. It's perfectly possible to have, say, an upper limit and then 3 or 4 or more or less values that are marked as outliers. It's perfectly possible to have the same thing in the lower half, and it's possible to have outliers on both halves. Okay, so in this illustration, the box plot only has one upper outlier. But that doesn't mean that you will always be drawing box plots with only one outlier on one side. You could have outliers on both sides, multiple outliers on one side compared to the other side. Any of these situations are possible. Okay. Now, the last thing that I want to go over just before I end the video is a quick discussion on shape. We've talked a lot about shape throughout the lecture set. Okay. Now, here, okay, what is the shape of the box plot? Well, remember, from a box plot, we can determine the skewness or the symmetry, but we cannot determine modality. So from this box plot, all we can say is that the shape of the box plot or the distribution of the data set is right skewed or positive skewed. Okay. Because you can see that the lower half of the data, so for example, the minimum Q1 and Q2, they are much closer together than the upper half of the data, Q2, Q3, and then the max and the upper outlier. Those are far more spread out. So the spread on the positive side indicates skew to the positive numbers or to the right. So when we have a really big dispersion on the upper half of the data and a tightness on the lower half, that's right skewness. If it was the other way around, that would be left skewness. And if everything was basically perfectly the same size, all the quadrants, that would be symmetry. But you can refer to the previous discussion on that I provided in set 2. Okay, so that's the end of this video. I hope that makes sense. And if you have any questions, please let me know.